Hello everybody, welcome to Soil Mechanics online course. Today we will start learning Chapter 1, Index Property of Soils and Soil Classification. In this lecture, I will talk about the formation and grain size of soil. As previously mentioned, soils are formed by weathering of rocks, either physically or chemically. Physical weathering involves reduction of size without changing the original composition of the parent rock. The main agent responsible for this process are exfoliation, unloading, erosion, free and thaw cycling, etc. Chemical weathering causes both reduction in size and chemical change of the parent rock. The main agent responsible for chemical weathering are hydration, carbonation, and oxidation. Often, chemical and physical weathering take place at the same time. Soils that remained at the site of weathering are called residue soils. These soils retain many of the elements that comprise the parent rock. Residue soils are usually strong and stable. Those soils that were transported by external agents such as wind, river, and streams are called transported soils. The composition of these soils depends on the environment under which they are transported and is often different from their parent rock. Many transported soils are soft and loose and may lead to serious problems. As discussed before, soil is a three-phase material consisting of solid particles with air and/or water filling the voids among the particles. The solid particles form the skeleton of soil, which controls its mechanical properties. According to this unified soil classification system, soils are broadly classified into two categories, namely coarse-grained soil and fine-grained soil. If more than 50% of the soil particles is greater than 75 micrometers, the soil is called coarse-grained soil. If more than 50% of the soil particles is finer than 75 micrometers, the soil is named fine-grained soils. Coarse-grained soils are subdivided into gravels and sands, while fine-grained soils are divided into silts and clays based on their sizes. Two common methods for determining particle size are sieve analysis and hygrometer analysis. Sieve analysis is used to determine the particle size of coarse-grained soil, and hygrometer analysis is used to determine the particle size of fine-grained soil. To perform a sieve analysis, the oven-joint soil is shaken through a stack of sieves with opening size decreasing from top to bottom. By determining the mass of soil retained on each sieve, one can calculate the percentage finer for each sieve. Hygrometer analysis is based on the principle of Stokes' law. The hygrometer test is conducted by mixing a small amount of soil into a suspension and observing how the suspension settles in time. Larger particles will settle quickly, followed by smaller particles. Combining the results of sieve analysis and hygrometer analysis on one graph, we can get the particle size distribution curve, or called the gradation curve, as shown in the picture. From particle size distribution curve, we can define several important parameters. For example, D50 is called average size, that is the diameter of the soil particles for which 50% of the particles are finer. Similarly, we can define D10, D30, and D60. Uniformity coefficient Cu is defined as D60 over D10, and coefficient of curvature Cc is defined as square of d30 over d10 times d60. Cu and Cc are two important parameters for evaluating the seepage stability of soils. Gradation curves for typical soils are presented in the figure. You may notice that the shapes of the curves are different. The gradation curve of soil A is nearly vertical, indicating that particles in soil A are nearly the same size. This is called poorly graded soil. The gradation curve B is flat and covers a wide range of particle size. This is called well-graded soil. According to the Unified Soil Classification System, a well-graded soil has a uniformity coefficient greater than 4 for gravels and 6 for sands, and a coefficient of curvature between 1 and 3. Look at gradation curve C. You can see that it has a horizontal section, suggesting that certain particle sizes are missing. This soil only has large and small particle sizes. This is called gap-graded soil. Soils can be manipulated by changing their gradation curves so that they can be used for different construction purposes. For example, well-graded soils can be used for constructing road embankment. The fine particles can fill the voids between large particles to form a dense structure. So after compaction, well-graded soils can have good mechanical properties. The poorly graded soils have good drainage capacity and they are suitable for drainage purpose. The gap-graded soils are sometimes used in a dam construction to build the impervious court wall. Well, that's all for today. See you next time.